Welcome back to mathematics classes, maths marathon. Continue with inverse trigonometric functions. This is the second class of inverse trigonometric functions, second lecture I can call. We'll continue in the previous video, the previous session. We've seen the trigonometric substitution. Whenever there is root of 1 minus x square, we put x equal to sine theta or cos theta depending upon the given conditions. Root of 1 plus x square, we put x equal to tan theta or cot theta. Just recalling the various substitutions where we stopped there. Root of x square minus 1, we put x equal to secant theta or x equal to cosec theta. If it is root 1 plus x or root 1 minus x, in that case we can put x equal to cos theta or cos 2 theta. All those things we learnt. And more generally also I gave in terms of root of a square minus x square, root of a square plus x square, root of x square minus a square, root of a plus x, root of a minus x in terms of a, the substitution. And also we had root of x by 1 minus x and root of 1 minus x by x, correct? Then we put x equal to sine square theta or x equal to cos square theta. Root of x by 1 plus x or root of 1 plus x by x, then we put x equal to tan square theta or x equal to cot square theta, correct? All those things required here and there to work out the problems. Not only in this chapter, we may also require it in chapters like differentiation and integration, especially those are preparing exclusively for JEE exams. Those kind of substitutions are commonly used in many problems. And if it is root of x by x minus 1 or root of x minus 1 by x, then we can put x equal to secant square theta or x equal to cosecant square theta. Okay, all those things I've discussed in the previous session. Now I'll continue with the problems now in this section. The first one we have, write tan inverse of x by root of a square minus x square for mod x less than a in the simplest form. This question already asked in the March 2024, last year, 3 marks question. And whenever there is root of a square minus x square, normally we put the substitution, put x equal to a sine theta. So I'll proceed with the substitution, put x equal to a sine theta. To write this in the simplest form, put x equal to a sine theta. Put x equal to a sine theta. The given expression is GE stands for given expression. Tan inverse of putting x equal to a sine theta. Wherever there is x, you put a sine theta. A sine theta divided by root of a square minus a square sine square theta is equal to tan inverse of numerator is a sine theta, denominator is take a square common inside the root. What remains? 1 minus sine square theta. Correct? This is equal to tan inverse of numerator, keep as it is, a sine theta divided by root of a square into 1 minus sine square theta is cos square theta, fundamental trigonometric identity. Correct? This is simplifies to tan inverse of numerator is a sine theta, denominator will be a cos theta, taking the square root, positive square root, correct? So a cancels, sine theta by cos theta is tan theta, so it simplifies to tan inverse of tan theta, which is equal to theta. Retrieve back theta from the substitution you made, because you put x equal to a sine theta, from there we get sine theta equal to x by a, correct? Sine theta is equal to x by a, or theta is equal to sine inverse of x by a from this. So this you can call equation 1. So from equation 1, substitute back, theta is equal to sine inverse of x by a using 1. Hence we get the simplified form. The question was given in terms of x, answer also we keep in terms of x. 3 marks question. Quite simple one. Because there is root of a square minus x square, we put x equal to a sine theta. Okay. Wherever there is x, you put a sine theta. Go on, simplify using trigonometric formulas. And tan inverse of tan theta is theta. tan inverse of tan theta is equal to theta is possible for all theta belongs to the principal branch of tan inverse. The principal branch of tan inverse is open interval minus pi by 2 to pi by 2. Correct? So that is satisfied for this condition. Mod x less than a can verify. So simplest form is this. Sine inverse of x by a. Another way of doing this problem, I can do it in 2 steps. Such a simple question this is. We can do it in another way. How you know? Tan inverse of x by root of a square minus x square. Directly I can convert it to sine inverse, expressing one inverse trigonometry function in terms of other. See, tan inverse of means what? It is opposite by adjacent. Tan theta is opposite side by adjacent side. You take a triangle. Say for example, take a triangle. Mark this angle as theta. Tan inverse of means it is opposite by adjacent. This is opposite side. This is adjacent side, right? So what is hypotenuse? Find out the hypotenuse. Square of this plus square of this. Then the root of that. So hypotenuse will be root of square of x square, plus square of this, a square minus x square. So what do you get? Root of a square. That is equal to a. Correct? Assume that a is positive. So now I can convert this. Tan inverse of means it is opposite by adjacent. Correct? In this triangle, can you define sine theta? In this triangle, if you define sine theta, it is equal to x by a. Correct? Sine theta is opposite by hypotenuse. What is theta is equal to? Sine inverse of x by a over 2 steps answer. Correct? This is also theta. Tan inverse of x by root of a square minus x square is theta. Same theta is equal to sine inverse of x by a. So simplest form of this is sine inverse of x by a. Same answer we got. Correct? Sine inverse of x by a. Simple question. Ask for 3 marks. But there are steps here. Carries marks. Okay? Please go through it. Practice all these problems. Those who are listening to my lecture, please work out these problems on your own. Try to understand first. Learn all the formulas. Then only it becomes easy. Mathematics means it contains formulas and equations only. So you have to learn all the formulas. Write and study the formulas is so important. Solution is given to you here. Go to the next one. Cot inverse 1 by root of x square minus 1 for x greater than 1. You have to write it in the simplest form. Simplest form you have to write. Because there is root of x square minus 1, here put x equal to secant theta. Put x equal to secant theta. Given expression becomes tan inverse of 1 by root of secant square theta minus 1. Wherever there is x, you put secant theta. Secant square minus 1 is what? Tan square theta, right? Secant square minus 1. No, cot inverse. The question is, sorry, I didn't see. Question is cot inverse. This is cot inverse. Given question, I didn't see. Just a minute. Sorry for the mistake. This is given as cot inverse. Cot inverse. So secant square minus 1 is tan square theta. You know that 1 plus tan square theta is equal to secant square theta, right? 1 plus tan square theta is equal to secant square theta. So tan square theta is equal to secant square theta minus 1. Correct? So secant square theta minus 1 is tan square theta. This is equal to cot inverse of 1 by secant square minus 1 tan square. Root of tan square is tan, assuming that it is positive. 1 by tan is cot. So this is cot inverse of cot theta. Cot inverse of cot theta is equal to theta. Substitute back for theta finally. From this, theta is equal to secant inverse of x. Call this equation star. Therefore, theta is secant inverse of x using equation star. Hence, we get the answer. The simplest form of this. The question is given in terms of x. Answer should be in terms of x. And inside the bracket there is no trigonometric function. In that case we make a substitution. Suitable substitution has to be made. Whenever there is no trigonometric function inside the bracket, we make a suitable substitution. Suitable trigonometric substitution. So that it should be possible for us to simplify. Okay. and the question is given in terms of x. Answer also is kept in terms of x. Hope you understand this. Solution is given here. Next one. Write tan inverse root 1 plus x square minus 1 by x for x not equal to 0 in the simplest form. This question already asked 2 times. March 2017 and September 2022. Karnataka PU board exams, I'm telling. I'll discuss even for CBSE also. 12th standard exams will discuss the papers, the special questions or the extra questions we have on this chapter. We'll be discussing all those things. I'm presently doing on NCERT, focusing on NCERT book. Now there is root of 1 plus x square. Whenever there is root of 1 plus x square, we make a substitution. Put x equal to tan theta. Or you can go for cot theta also. But here I'll put x equal to tan theta and simplify this. Put x equal to tan theta. Put x equal to tan theta. Given expression becomes what? Tan inverse of root of 1 plus tan square theta minus 1 divided by tan theta. Putting x equal to tan theta. 1 plus tan square theta is secant square theta. Root of secant square theta is secant theta. Assuming that secant theta is positive here. Correct? Secant theta minus 1 divided by tan theta. Secant is 1 by cos. Tan is sine by cos. Secant is 1 by cos. Tan is sine by cos. Is equal to tan inverse of, what do you get? 1 minus cos theta divided by cos theta divided by sin theta divided by cos theta. Correct? Take LCM, cos theta. 1 minus cos theta by cos theta. Sin theta by cos theta. Cos theta will cancel. This is equal to tan inverse of, what is 1 minus cos theta? Half angle formula we have. 2 sin square theta by 2. And sin theta is 2 sin theta by 2 cos theta by 2. Using half angle formula. 2 cancels. Sin square means sin into sin. So 1 sin will cancel here. 1 sin remains here. Sin by cos is tan. Tan inverse of tan theta by 2. Tan inverse of tan theta by 2 is theta by 2. Theta by 2 means what? Half into theta. Correct? Retrieve back theta from this. Because you put x equal to tan theta, theta is equal to tan inverse of x. So the simplified form is half into tan inverse of x using the above equation. Simplified form, you better remember this because this is a very standard problem. It's required even in differentiation and integration. They can ask you to differentiate this. So first you have to simplify it. If they ask you to differentiate this function, no, first you simplify. In a CET exam, if this question is asked to differentiate, we can't do all these steps, correct? It takes so much of time. So it's better to remember this. The simplified form of tan inverse root 1 plus x square minus 1 by x is half tan inverse x. 1 by 2 tan inverse x. Remember this. And if you are asked to differentiate this, just differentiate this. Derivative of half tan inverse x. Half is constant, keep as it is. Derivative of tan inverse x. 1 by 1 plus x square. So simple question. Practice all these things, okay? For those who are learning for the first time, you can go through it, understand it, learn all the first few formulas, then only it becomes easy, okay? 1 plus tan square theta is secant square theta, root of secant square is sec, sec is 1 by cos, tan is sine by cos, taking LCM, using half angle formulas, 1 minus cos theta, 2 sine square theta by 2. Sin theta, 2 sin theta by 2 cos theta by 2. Half angle formulas are used. Then simplify it and then finally substitute back for theta. Hope you understand this. Solution is given to you here. And the next one, prove that sin inverse of 2x into root of 1 minus x square equal to 2 sin inverse x. The condition is given, x lies between minus 1 by root 2 and 1 by root 2. So a very important one problem because I got another question similar to this where left hand side is same but right hand side is different and the conditions are different. Okay, concentrate on this. Already asked so many times. March 2015, September 2020, April 2022, March 2024 for 2 marks. So because there is root of 1 minus x square, we go for the substitution, put x equal to sine theta. Whenever there is root of 1 minus x square, you can go for x equal to sine theta or x equal to cos theta. In this case, I'll go for the substitution x equal to sine theta. Put x equal to sine theta here. Put x equal to sine theta. Start from LHS. LHS equal to sine inverse of 2 into putting x equal to sine theta, 2 sine theta into root of 1 minus sine square theta. Correct? This is equal to sine inverse of 2 sine theta into 1 minus sine square is cos square, root of cos square is cos theta. This is equal to sine inverse of what is 2 sine theta cos theta, sine 2 theta. Sine inverse of sine 2 theta is 2 theta if 2 theta belongs to the principal branch of sine inverse. What is the principal branch of sine inverse? The closed interval minus pi by 2 to pi by 2. Correct? Now I can deduce the condition as well. But in the exam, you don't have to write all the conditions for theory exams. But you must know how the conditions are got. Okay? So theta is what? Sine inverse of x. Because x is sine theta, substitute back. Theta is equal to sine inverse of x. So this becomes equal to 2 sine inverse of x is equal to RHS. Starting from LHS, we get RHS. Just put x equal to sine theta. Root of 1 minus sine square theta. 1 minus sine square is cos square theta. Root of cos square is cos theta. 2 sine theta cos theta is sine 2 theta. Double angle formula we have, correct? Sine inverse of sine 2 theta is 2 theta. This is possible only if 2 theta belongs to the principal branch of sine inverse. 2 theta belongs. What is the principal branch of sine inverse? Closed interval minus pi by 2 to pi by 2. From this, theta belongs to the interval minus pi by 4 to pi by 4. Theta belongs to this minus pi by 4 to pi by 4. Theta is what? Sine inverse of x. Sine inverse of x belongs to the interval minus pi by 4 to pi by 4. Correct? Substitute back for theta from this. Theta is sine inverse of x. So x belongs to which interval? X belongs to the interval sine of minus pi by 4 minus 1 by root 2. Sine pi by 4 is 1 by root 2. So x belongs to the interval minus 1 by root 2 to 1 by root 2. That is what the condition is given to us here. Hope you understand how the condition is also deduced. We can come to know. Sine inverse of sine 2 theta is equal to theta is possible only if 2 theta belongs to the principal branch of sine inverse. The principal branch of sine inverse is the closed interval minus pi by 2 to pi by 2. From 2 theta you get theta by dividing by 2. Then theta you substitute back. So x belongs to sine of minus pi by 4 is minus 1 by root 2. Sine pi by 4 is 1 by root 2. Hope you understand this. Please make a note of this. Very important. They can ask you to differentiate this also with conditions given to you. If the condition is minus 1 by root 2 to 1 by root 2, put x equal to sine theta. Otherwise, you can put x equal to cos theta. Other condition is 1 by root 2 to 1. I'll explain to that also, that question later after this. Look at this question. Sine inverse of 2x into root of 1 minus x square equal to cos inverse x. The right hand side is different and the condition is different. So in this case, we put x equal to cos theta here. Put x equal to cos theta. Start from left hand side. LHS equal to sine inverse of putting x equal to cos theta. 2 cos theta into root of 1 minus cos square theta. You believe it or not, this question is asked even in the CET exam this year, 2025. Also, the same question was asked in CET 2012. How they asked the question? This equation is given to you. Sine inverse of 2x into root of 1 minus x square equal to cos inverse of x. That holds for which values of x they ask. The answer is 1 by root 2 to 1. The closed interval 1 by root 2 to 1. This is the answer to be given. This was the question asked. This equation holds for which values of x? That was the question. Twice asked, same question. Once in KCET 2012 and recently KCET 2025. 2 times same question is asked. Sine inverse of this is equal to 2 cos theta into 1 minus cos square theta is sin square theta. Root of sin square theta is sin theta. Is equal to sine inverse of what is 2 cos theta sin theta sin 2 theta. Sine inverse of sin 2 theta is 2 theta. Theta is substitute back. Theta is equal to cos inverse of x. Correct? So 2 times cos inverse of x is equal to RHS. Hope you understand the proof of this. And the condition part, how to deduce this condition, that also I'll show, because if you understand all these things, it becomes easy for even competitive exams. See, sine inverse of sine 2 theta is equal to 2 theta is possible only if 2 theta belongs to the principal branch. 2 theta belongs to the principal branch of sine inverse. What is the principal branch of sine inverse? Closed interval minus pi by 2 to pi by 2. Correct? Minus pi by 2 to pi by 2. So theta belongs to what? Divide by 2. Theta belongs to the interval minus pi by 4 comma pi by 4. What is theta? Theta substitute back. Theta is cos inverse x according to this. That is cos inverse of x. Cos inverse of x belongs to the interval minus pi by 4 to pi by 4. But blindly don't continue further. Cos inverse of x range is what? 0 to pi. Cos inverse of x will lie in the interval 0 to pi. Cos inverse of x, answer what you get, the range of cos inverse x can't take negative values. Meaningless it becomes. So minus pi by 4 to pi by 4 is not possible. Minus pi by 4 to pi by 4, this interval is not possible for cos inverse, because cos inverse of x is always greater than or equal to 0. Correct? But cos inverse of x belongs to the interval 0 to pi. Hope you understand this. That is the range of cos inverse of x. So cos inverse of x can't lie in the interval minus pi by 4 to 0. That has to be deleted. Correct? So according to the working method, we got cos inverse of x belongs to minus pi by 4 to pi by 4. But what we know, the range of cos inverse of x is the closed interval 0 to pi. That means it lies either in the first quadrant or in the second quadrant. Negative angle is not possible for cos inverse. So I'll take the intersection of these two. Intersection of these two, if you take, the common value is going to be 1 intersection 2. 1 intersection 2 is cos inverse of x will belong to the interval 0 to pi by 4. 0 to pi by 4 is common. So from there I can write x will belong to which interval? Cos 0 is 1. Take cos on either side. Cos is a decreasing function. So when the decreasing function comes, to interchange and write. Okay, cos 0. Cos 0 is 1. Correct? And cos pi by 4 is 1 by root 2. Interchange and write. So x belongs to the interval 1 by root 2 to 1. Because cos is a decreasing function. Decreasing function means what? As increase the value of x, the function value decreases. Decreasing function is something like this. x1 is less than x2. In fact, I'm telling about strictly decreasing function. Cos x1 is greater than cos x2. Inequality is going to reverse. That we're going to discuss in detail in increasing and decreasing function. So I interchange and write. Don't write cos 0 1 and cos pi by 4 1 by root 2. While writing the interval, always write the smaller number first, then write the larger number. We can't write 1 comma 1 by root 2 interval. So that is a condition reduced here. X belongs to the interval 1 by root 2 to 1. Hope you understand this. While solving, we got like this. Cos inverse of x belongs to the interval minus pi by 4 to pi by 4. This is 0. This is pi by 2. This is pi. Correct? This is minus pi by 2 here, negative angle. So minus pi by 4 to pi by 4, something like this. Cos inverse of x will lie between 0 to pi. 0 to pi. So common is only this. This part is common. 0 to pi by 4 is common. Correct? So that is what I took the intersection of 1 and 2, because cos inverse of x can't take the negative angles. Negative value is not possible for cos inverse of x. It can't lie in the interval minus pi by 4 to 0. And intersection of these two gives 0 to pi by 4. Hope you understand this. Otherwise, you take a number line and represent minus pi by 4 to pi by 4, 0 to pi. Common is 0 to pi by 4. Hope you understand this. Minus pi by 4 is here, 0 is here, pi by 4 is here, correct? Pi is here. according to the range of cos inverse x 0 to pi. Range of cos inverse x. According to the method of solving, you got minus pi by 4 to pi by 4. What is common to both of this? Common is this 0 to pi by 4, correct? So cos inverse of x belongs to 0 to pi by 4. X belongs to cos 0, 1, cos pi by 4, 1 by root 2. Interchange and write because cos is a decreasing function. Hope you understand this. Better remember this condition also. Okay. Sin inverse of 2x into root of 1 minus x square equal to 2 cos inverse of x for x between 1 by root 2 and 1. Same left hand side with different right hand side with condition is different. What is that we have? The other one we had sin inverse of 2x into root of 1 minus x square is equal to 2 sin inverse of x is equal to 2 sin inverse of x for x between minus 1 by root 2 and 1 by root 2. And this becomes equal to 2 cos inverse of x for x between 1 by root 2 and 1. X between 1 by root 2 and 1. Learn this. Left hand side is same, right hand side is different, conditions are different. Important one. Please make a note of this. I think here root of is missing here. Root of 1 minus cos square theta in the solution. Okay. Next one, prove that tan inverse root 1 plus x minus root 1 minus x by root 1 plus x plus root 1 minus x. Want to prove that equal to pi by 4 minus half cos inverse x. Whenever there is root 1 plus x or root 1 minus x, we make a substitution, put x equal to cos theta, or you can go for x equal to cos 2 theta. I'll put x equal to cos theta and prove this. Put x equal to cos theta. Put x equal to cos theta. LHS equal to what? Left hand side. Tan inverse of square root of 1 plus cos theta minus root of 1 minus cos theta. Root of 1 plus cos theta plus root of 1 minus cos theta. Correct? Putting x equal to cos theta. What is 1 plus cos theta? 2 cos square theta by 2. 1 minus cos theta. 2 sin square theta by 2. Tan inverse of root of 1 plus cos theta. 2 cos square theta by 2. 1 minus cos theta is 2 sin square theta by 2. Half angle formula. Here 1 plus cos theta is 2 cos square theta by 2 plus root of 1 minus cos theta is 2 sin square theta by 2. This is equal to tan inverse of, this becomes what? Root 2 into cos theta by 2 minus root 2 into sin theta by 2 divided by denominator root 2 into cos theta by 2 plus root 2 into sin theta by 2. Root 2 is common in the numerator as well as in the denominator. Taking out root 2 common and cancelling it, what we get? Tan inverse of root 2 common. So what we get? Cos theta by 2 minus sin theta by 2 by root 2 into cos theta by 2 plus sin theta by 2. Root 2 cancels. Whenever you get expression of this type, cos minus sin by cos plus sin, what we do? We divide numerator and denominator by cos. So this becomes tan inverse of divide numerator and denominator by cos. Cos theta by 2 divided by cos theta by 2 minus sin theta by 2 divided by cos theta by 2. Dividing numerator and denominator by cos. Cos by cos is 1. Sin by cos is tan. Cos theta by 2 divided by cos theta by 2. Plus sin theta by 2 divided by cos theta by 2. Dividing both numerator and denominator by cos. So cos by cos is 1. Sin by cos is tan. Correct? Denominator. Cos by cos is 1. Sin by cos is tan. 1 minus tan theta by 2 by 1 plus tan theta by 2. That is tan of pi by 4 minus theta by 2. Tan of pi by 4 minus theta by 2, which is equal to pi by 4 minus theta by 2. What is theta? Substitute back. Theta is cos inverse of x. Because we put x equal to cos theta, theta is cos inverse x. So we get pi by 4 minus theta by 2 means half into theta. Correct? Theta by 2 is half into theta. Substitute back for theta finally. Pi by 4 minus half cos inverse x is equal to right hand side. Hence proved. Just go on doing it mechanically. Just putting x equal to cos theta because of the presence of root 1 plus x and root 1 minus x. Then make use of the half angle formula. 1 plus cos theta, 2 cos square theta by 2, 1 minus cos theta, 2 sin square theta by 2. Taking root 2 common from the numerator, denominator, cancelling it out. Whenever you get expression of this type, cos minus sine by cos plus sine, you divide numerator and denominator by cos. Cos by cos 1, sine by cos tan, and we know this formula. 1 minus tan theta by 2 by 1 plus tan theta by 2 is tan of pi by 4 minus theta by 2. Tan inverse of tan of pi by 4 minus theta by 2 is pi by 4 minus theta by 2. Finally, substitute back for theta. Theta is cos inverse of x. So that is equal to RHS. Hence proved. Hope you understand this simple question. We need to practice all these things if you are learning it for the first time. And next we got double angle and triple angle formulas. These are double angle formulas here. Sine 2 theta, cos 2 theta, tan 2 theta. Learn all these formulas required here and there. Already you learned this in first year. Sine 2 theta is 2 sin theta cos theta is equal to 2 tan theta by 1 plus tan square theta. Cos 2 theta, cos square theta minus sin square theta equal to cos square theta minus 1 equal to 1 minus 2 sin square theta equal to 1 minus tan square theta by 1 plus tan square theta. Tan 2 theta is 2 tan theta by 1 minus tan square theta. Sin 3 theta, 3 sin theta minus 4 sin cube theta. Cos 3 theta, 4 cos cube theta minus 3 cos theta. Tan 3 theta is 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Learn all these formulas, quite important. Double angle and triple angle formula. Because of the presence of 2 theta, it's called as double angle. Because of the presence of 3 theta, it's called as triple angle formula. Prove that 3 sin inverse of x equal to sin inverse of 3x minus 4x cube. I'll start from RHS. Put x equal to sin theta. If you put x equal to sin theta, 3 sin theta minus 4 sin cube theta, which is sin 3 theta. Put x equal to sin theta. Start from RHS. Put x equal to sin theta. Start from right hand side. Sin inverse of 3 sin theta minus 4 sin cube theta. Correct? This is equal to sin inverse of terms inside the bracket is sin 3 theta. Just now I told the formula. Sin inverse of sin 3 theta is equal to 3 theta. Substitute back for theta. Theta is sin inverse of x. Substitute back. So 3 times sin inverse of x, which is equal to LHS. Starting from right hand side, we get the left hand side. Hence proved. And the condition part also I'll prove how this condition is deduced. X belongs to the interval, closed interval, minus half to plus half. See, sin inverse of sin 3 theta will become 3 theta only if 3 theta belongs to the principal branch of sin inverse. What is the principal branch of sin inverse? The closed interval minus pi by 2 to pi by 2. So theta belongs to which interval? Theta belongs to the interval minus pi by 6 to pi by 6 dividing by 3. Theta is what? Sin inverse of x. Substitute back. That is, sin inverse of x will belong to the interval minus pi by 6 to pi by 6. Take sin on both of this. Sin of sin inverse x will be x. Belongs to. Sin of minus pi by 6 is minus half. Sin pi by 6 is half. That means this equation holds only if x belongs to the interval minus half to plus half. Only in that interval the equation is true. If you take a value of x outside the interval, the equation will not be true. Say x equal to 1 is not there in this. X equal to 1 is not there, right? I'll put x equal to 1 in LHS and RHS, will not get equal. If you put x equal to 1, suppose, put x equal to 1. Outside the interval, I have taken a value. Left hand side is what? 3 sine inverse 1. 3 times sine inverse of 1. 3 into. What is sine inverse of 1? Pi by 2. RHS. RHS is equal to. Put x equal to 1. RHS, what we get? Sine inverse of 3 into 1. Putting x equal to 1. 3 into 1, 3. Minus 4 into 1 cube, 4. Correct? So 3 minus 4 is minus 1. Sine inverse of minus 1 we get. That is equal to minus pi by 2. See, they are not equal. If you take a value of x outside the interval, then the equation is not satisfied. That is, equation is not true. So 3 sine inverse of x will be equal to sine inverse of 3x minus 4x cube for all x belongs to this interval. Minus half to plus half. Only in that interval the equation is true. LHS equal to RHS is possible only for x belongs to the closed interval minus half to plus half. Hope you understand this. If you take a value of x outside the interval, then the equation is not satisfied. LHS will not be equal to RHS. Here we got 3 pi by 2. Here I got minus pi by 2. LHS not equal to RHS. Hope you understand this. Next one. Same type of question we have. Prove that cos inverse x. Prove that 3 cos inverse x here. Sorry. Prove that 3 cos inverse x. Correct it. The question is prove that 3 cos inverse x. 3 cos inverse x is equal to cos inverse of 4x cube minus 3x. Start by putting x equal to cos theta. Put x equal to cos theta. Start from RHS. RHS is equal to what we have? Cos inverse of 4 cos cube theta minus 3 cos theta. Terms inside the bracket is cos 3 theta, right? Cos inverse of cos 3 theta, which is equal to 3 theta. Substitute back for theta. Theta is cos inverse of x. So this is equal to 3 times cos inverse of x is equal to LHS. Starting from RHS, we get LHS. And how is the condition reduced? Cos inverse of cos 3 theta will be 3 theta if 3 theta belongs to the principal branch of cos inverse. What is the principal branch of cos inverse? 0 to pi. Theta belongs to 0 by 3, 0. This is pi by 3. What is theta? Theta is cos inverse of x. Cos inverse of x belongs to interval 0 to pi by 3. So take cos on both sides. Cos of cos inverse x is x. Cos 0 is 1. Cos pi by 3 is half. You have to interchange and write. Interchange and write. Don't write as it is. Cos 0 is 1. Cos pi by 3 is half. Interchange and write because cos is a decreasing function. So x belongs to the interval half to 1. So this equation is a true for x belongs to half to 1. Hope you understand this. Just putting x equal to cos theta and using the triple angle formula. 4 cos cube theta minus 3 cos theta is cos 3 theta. Cos inverse of cos 3 theta equal to 3 theta. Substitute back for theta. Hence RHS, starting from RHS we get LHS. And also I proved the condition. X belongs to the closed interval half to 1. Next one. Solution is given here. Next one. Prove that. Here also there is one correction. 2 tan inverse of x. Okay, here. Prove that is 2 tan inverse of x. Not just tan inverse of x. 2 tan inverse of x is equal to cos inverse of 1 minus x square by 1 plus x square. Here to prove this we put x equal to tan theta. Start from RHS. Put x equal to tan theta because we know the formula. 1 minus tan square theta by 1 plus tan square theta is cos 2 theta. Correct? Cos inverse of 1 minus tan square theta divided by 1 plus tan square theta. What is 1 minus tan square theta by 1 plus tan square theta? Cos 2 theta. Cos inverse of cos 2 theta is 2 theta. Theta substitute back. Theta is tan inverse of x. Correct? So substitute back for theta. We get 2 tan inverse of x is equal to LHS. And also I can reduce the condition for you. Cos inverse of cos 2 theta is equal to 2 theta. Possible only if 2 theta belongs to the principal branch of cos inverse. What is the principal branch of cos inverse? 0 to pi. Correct? 0 to pi. So theta belongs to the interval. Divide by 2. 0 by 2, 0. Pi by 2. correct? Dividing by 2. What is theta? Substitute back. Theta is tan inverse x. Tan inverse x belongs to the interval 0 to pi by 2. So x belongs to what? Tan 0 is 0. Tan pi by 2 is infinity. Infinity has to be excluded always, correct? We write open for infinity, closed open interval, because infinity and minus infinity are always excluded. They are not to be included under real numbers. So x belongs to closed open interval 0 to infinity. Same as telling x greater than or equal to 0. That is what we have. X greater than or equal to 0. X belongs to the closed open interval 0 to infinity. Hope you understand this. Next one. Prove that 2 tan inverse of x equal to sine inverse of 2x by 1 plus x square. Here also we put x equal to tan theta. Start from right hand side. Okay. Put x equal to tan theta. Start from right hand side. Right hand side you start. RHS is equal to sine inverse of 2 tan theta divided by 1 plus tan square theta. 2 tan theta by 1 plus tan square theta is sine 2 theta. Correct? Sine inverse of sine 2 theta. Sine inverse of sine 2 theta is equal to 2 theta if 2 theta belongs to the principal branch of sine inverse. What is the principal branch of sine inverse? Closed interval minus pi by 2 to pi by 2. If 2 theta belongs to this interval, theta belongs to divide by 2 and write minus pi by 2 by 2 minus pi by 4 comma pi by 4. What is theta? Substitute back. Because x is tan theta, theta is equal to tan inverse of x. So tan inverse of x will belong to this interval minus pi by 4 to pi by 4. Tan inverse of x belongs to closed interval minus pi by 4 to pi by 4. This implies x belongs to tan of minus pi by 4 is minus 1, tan pi by 4 is 1. X belongs to the closed interval minus 1 to plus 1. Finally, substitute back for theta here. 2 into tan inverse of x is equal to LHS. Hope you understand this. Also, the condition has been reduced here. Learn all these formulas if possible. It is quite useful even in chapters like differentiation and integration. Okay. Solution is given here. Next one. This also you can prove on your own by putting x equal tan theta. It is similar to the earlier two questions we did. By putting x equal tan theta, start from RHS. We'll get the answer. Put x equal to tan theta. Put x equal to tan theta. Start from right hand side. RHS is equal to tan inverse of 2 tan theta divided by 1 minus tan square theta. 2 tan theta by 1 minus tan square theta. Correct? Is equal to tan inverse of terms inside the bracket is tan 2 theta. Tan inverse of tan 2 theta is equal to 2 theta if 2 theta belongs to the principal branch of tan inverse. What is the principal branch of tan inverse? Open interval minus pi by 2 to pi by 2. Principal branch of tan inverse is open interval minus pi by 2 to pi by 2. So theta belongs to the open interval minus pi by 4 to pi by 4 dividing by 2. Substitute back for theta. What is theta? Tan inverse of x. Theta is tan inverse of x. That is tan inverse of x belongs to the open interval minus pi by 4 to pi by 4. X belongs to what? Tan of minus pi by 4 is minus 1. Tan pi by 4 is 1. So this is equal to 2 times tan inverse of x. That is equal to LHS. Starting from RHS we get LHS. Hence proved. Even the condition is reduced. X belongs to the interval, open interval minus 1 to plus 1. Learn how to reduce the condition. Because if you ask the value of x outside this interval, then also we can reduce the condition. All those things I'll be doing in CET synopsis or JEE level questions. Okay. There I'll be discussing. Now I'm just discussing the NCERT problems with concepts. Prove that next one. Tan inverse root x equal to half cos inverse 1 minus x by 1 plus x. We start from RHS. RHS is start. RHS is equal to half cos inverse of 1 minus x by 1 plus x. We can write x as root x square. Because there is root x you can see on the left hand side. I'll write cos inverse of 1 minus x is root x square divided by 1 plus root x square. Correct? Put root x equal to tan theta. Instead of x, now there is root x. So put root x is equal to tan theta. What we get? Half cos inverse of 1 minus tan square theta divided by 1 plus tan square theta. This is equal to half cos inverse of terms inside the bracket is cos 2 theta. Correct? That is equal to half into cos inverse of cos 2 theta is 2 theta. 2 cancels. We get theta. Correct? Substitute back for theta finally. Theta is tan inverse of root x. Because root x equal to tan theta, theta is tan inverse of root x. Tan inverse of root x. That is equal to LHS. Hence proved. Hope I understand this. And cos inverse of cos 2 theta is 2 theta only if 2 theta belongs to the principal branch of cos inverse. The principal branch of cos inverse is 0 to pi. Correct? Then you can deduce the condition there also. Next one. Write this expression in the simplest form for mod x less than a by root 3. Given expression is tan inverse of 3a square x minus x cube divided by a cube minus 3ax square. If it was like this, suppose the given question was tan inverse of 3x minus x cube divided by 1 minus 3x square. If this was a question given to you, then I could put x equal to tan theta and simplify it, and you will get the answer as 3 tan inverse of x. 3 tan inverse of x. We could simplify this by putting x equal to tan theta. Correct? By putting x equal to tan theta, we can simplify this. We compare this and this. What is the observation? In place of a cube, there is 1 no here. So that is one observation. And here 3a square x. Here it is just 3x. So a is extra part present here. Correct? Here it is 3x square, but here it is 3ax square. I'll reduce this expression to this form so that I can simplify it. To make it to that form, to reduce this to that form, what we'll do is we'll divide both numerator and denominator by a cube. Divide both numerator and denominator by a cube. Both numerator and denominator by a cube. So what do you get? In that case, tan inverse of 3a square x divided by a cube minus x cube divided by a cube. Here a cube by a cube minus 3ax square divided by a cube. Dividing by a cube for both numerator and denominator. This is equal to tan inverse of, what do you get? A square cancels. This becomes 3x by a minus x cube by a cube is x by a the whole cube divided by a cube is 1 minus 3. 1a cancels. X square by a square is x by a the whole square. Correct? Simplifying like this. A square cancels here. So 3x by a. X cube by a cube is x by a the whole cube. A cube by a cube is 1. And here 1a cancels. 3 x square by a square is x by a the whole square. Now you put x by a equal to tan theta to simplify this. Put x by a is equal to tan theta. What we get? Tan inverse of 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Putting x by a equal to tan theta. Terms inside the bracket is nothing but tan 3 theta. So tan inverse of tan 3 theta is equal to 3 theta. So substitute back for theta from this. Theta is equal to tan inverse of x by a. Correct? So simplified form is 3 times tan inverse of x by a. Hope you understand this. Next one. To simplify this expression. Here sine inverse of 2x by 1 plus x square plus cos inverse 1 minus y square by 1 plus y square is there. So for x we'll put sine alpha put x equal to sine alpha, and you put y equal to, put x equal to tan alpha, not sine alpha, just a minute, made a mistake. Put x equal to because we know the formula, correct? 2 tan alpha by 1 plus tan square alpha. Put x equal to tan alpha here. Put x equal to tan alpha and y is equal to tan beta. Y is equal to tan beta. Because we know the formula. 2 tan alpha by 1 plus tan square alpha is sine 2 alpha. 1 minus tan square beta by 1 plus tan square beta is cos 2 beta. Because of the multiple angle formulas we have, the given expression becomes tan of 1 by 2 into sine inverse of 2x. X is tan alpha divided by 1 plus tan square alpha plus cos inverse of 1 minus y is tan beta. So 1 minus tan square beta divided by 1 plus tan square beta. This is equal to tan of 1 by 2 into sine inverse of 2 tan alpha by 1 plus tan square alpha is sine 2 alpha, correct? Plus cos inverse of 1 minus tan square beta by 1 plus tan square beta is cos 2 beta. That's equal to tan of 1 by 2 into sine inverse of sine 2 alpha is 2 alpha. Cos inverse of cos 2 beta is 2 beta. Take 2 common from this and simplify. Tan of 1 by 2 into 2 common, and you can write this alpha plus beta. 2 cancels. Tan of alpha plus beta again. What is tan of alpha plus beta? We know tan alpha plus tan beta divided by 1 minus tan alpha into tan beta. What is tan alpha? Substitute back x. Tan alpha is x and tan beta is y divided by 1 minus xy. So we get a simplified form as x plus y divided by 1 minus xy. Hope you understood this. Move on to the next one. Again, the table here. This is already we have done so many questions. I can remember the conditions, the equation, and the domain of the equation, where the condition is the satisfied, where for which values of x the equation holds is given. Domain of the equation, and the most important is these two. These two is the most important because the left hand side is same but right hand side is different and the conditions are different. Already I have reduced the condition as well, correct? In each of the cases I reduced the condition. In most of the cases I have reduced the condition. So please remember this, okay, equation, this table. If you remember, it's better. All the problems we've done so far is given as a summary. Remember this. For CET and other competitive exams you can memorize this. Expressing inverse trigonometry function in terms of each other. Next concept. Say sine theta is equal to x. X means x by 1, right? Sine theta is x. X means x by 1. So this is sine theta. I marked the angle as theta here. Sine theta is opposite by hypotenuse, x by 1. So adjacent side becomes root of 1 minus x square. Because square of this plus square of this is square of this. Square of this how much? X square. Square of this how much? 1 minus x square. 1 minus x square plus x square is 1, which is 1 square. So it satisfies the Pythagoras theorem. So if sine theta is equal to x by 1, cos theta is root 1 minus x square by 1. Cos theta is adjacent side by hypotenuse. Tan theta is opposite by adjacent. That is what is given. Sine theta is x. Cosec theta is 1 by x. Cosec is reciprocal of sine. Correct? Sine theta is x by 1. Cosec theta is 1 by x. And cos theta is root 1 minus x square by 1. So secant theta is 1 by root of 1 minus x square. Tan theta is x by root of 1 minus x square. Tan theta is opposite by adjacent. And cot theta is adjacent by opposite. So cot theta is root of 1 minus x square by x. So if you start with sine theta is equal to x, I can find the values of the remaining trigonometric functions in terms of x. That is what we have done here. And from the above, we conclude that for all x belongs to the closed interval 0 to 1. See, sin theta is x means theta is a sine inverse of x. Here theta is cos inverse root 1 minus x square. Here theta is cosec inverse 1 by x. Here theta is sec inverse 1 by root of 1 minus x square. Here theta is tan inverse x by root of 1 minus x square. Theta is cot inverse root 1 minus x square by x. Correct? That is what? All of them are theta. So we have the relationship. We are expressing one inverse trigonometry function in terms of other. For all x belongs to the closed interval 0 to 1, we have this following. Sin inverse of x equal to cos inverse of root 1 minus x square is equal to tan inverse of x by root of 1 minus x square equal to cosec inverse of 1 by x is equal to secant inverse of 1 by root of 1 minus x square equal to cot inverse of root 1 minus x square by x. So if you know how to write the triangle, taking the sides, you can define on your own. Not to memorize all this, just understand the concept. How to express one inverse trigonometry function in terms of other. Same way I given it for cos theta is equal to x. Starting from cos theta is equal to x means x by 1, right? Cos theta is adjacent by hypotenuse. So opposite side will be root of 1 minus x square to satisfy the Pythagoras theorem. Cos theta is x by 1, secant theta is 1 by x. And sin theta is root of 1 minus x square by 1. Cosec theta is 1 by root of 1 minus x square. Tan theta is root 1 minus x square by x. And cot theta is x by root of 1 minus x square. Then you can define inverse of this. Theta is cos inverse x. Here theta is secant inverse 1 by x. Theta is sin inverse root 1 minus x square. Likewise others. So the relationship expressing one inverse trigonometry function in terms of other. Hope you understand this. If sine inverse of means it is the value is opposite by hypotenuse. Tan inverse of means that value is opposite by adjacent, like that. Go on, simplify. Same way given from tan theta is equal to x. X means x by 1. So hypotenuse is root of 1 plus x square, not 1 minus. Root of 1 plus x square. Okay. Hypotenuse is root of 1 plus x square because of Pythagoras theorem. And you can define sin theta opposite by hypotenuse x by root of 1 plus x square, cos theta 1 by root of 1 plus x square, tan theta x by 1, cot theta 1 by x, cosec theta root 1 plus x square by 1, secant theta root 1 plus x square, secant theta is root 1 plus x square by 1 and cosec theta is root 1 plus x square by x. All these things given. Then take the inverse of that, you get the answer. All these things by taking the inverse, all of them will be equal to theta, hence we have the relationship here. All these things you can get the concepts and you can remember this. Some of the important Pythagorean triplets you can remember. I given the list of Pythagorean triplets. Any three numbers which satisfies the Pythagoras theorem is called as Pythagorean triplets. 3, 4, 5, 6, 8, 10, 5, 12, 13 because 5 square plus 12 square is 13 square. 8, 15, 17, correct? Because 8 square plus 15 square is 17 square. 7 square plus 24 square is 25 square. 15 square plus 20 square is 25 square. Some of the important Pythagorean triplets. Any three numbers which satisfies the Pythagoras theorem are called as Pythagorean triplets. And using this now I can just give a conclusion of this. Sin inverse of 3 by 5 is cos inverse of 4 by 5. 3 by 5, 3, 4 and 5 forms the sides of a right angle triangle. No, 3, 4 and 5. So sin inverse of 3 by 5 is cos inverse of 4 by 5. Sin inverse of means opposite by hypotenuse. That is cos inverse of adjacent by hypotenuse. Tan inverse of opposite by adjacent. Like that. Cosec inverse of reciprocal of this. Hypotenuse by opposite. Secant inverse of hypotenuse by adjacent. Cot inverse of adjacent by opposite. Like that. Similarly for others, in terms of 12, 5 and 13 are given, 8, 15, 17 are given some of the important expression connected to inverse trigonometry functions. Pythagorean triplets already explained to you. And there are some problems here connected to this. Cos inverse 4 by 5 plus cos inverse 12 by 13 equal to cos inverse 33 by 65 we want to prove. We'll take the first angle as alpha. Let alpha is equal to cos inverse of 4 by 5. Take the first angle as alpha. Second angle as beta. Cos inverse of 12 by 13. Take the first angle as alpha and second angle as beta. So I'll start with cos of, because right hand side is cos inverse. Consider cos of alpha plus beta. Consider cos of alpha plus beta. So from this what you can write, cos alpha is 4 by 5, correct? Alpha is cos inverse 4 by 5, so cos alpha is 4 by 5. Here cos beta is equal to 12 by 13. If cos alpha is 4 by 5, sin alpha is going to be equal to 3 by 5, correct? Cos is adjacent by hypotenuse, sin is opposite by hypotenuse, because 3, 4 and 5 are Pythagorean triplets, and cos beta is 12 by 13 implies sin beta is equal to 5 by 13. Correct? Because 12, 5 and 13 are Pythagorean triplets. If you don't know, you can draw the triangle and find out. Cos alpha is 4 by 5. Draw the triangle and mark the angle as alpha. Cos is adjacent side by hypotenuse. So opposite side will be 3. So if cos alpha is 4 by 5, cos is 4 by 5 and sin is 3 by 5. Take another triangle and mark the angle as beta. Angle is beta. Here cos beta is 12 by 13. Correct? Hypotenuse is 13, so opposite side becomes 5. If cos beta is 12 by 13, sin beta is 5 by 13. Now you can write the compound angle formula for cos of alpha plus beta. What is cos of alpha plus beta? Cos alpha cos beta minus sin alpha sin beta. Cos alpha cos beta minus sin alpha sin beta. What is cos alpha? 4 by 5. Cos beta, substitute 12 by 13. Minus sin alpha is 3 by 5, sin beta is 5 by 13. Multiply numerator to numerator, 12 into 4, 48, 5 into 13, 65, 3 into 5, 15, 5 into 13, 65. Take LCM, 65. So what do you get? 48 minus 15, 33. Cos of alpha plus beta is 33 by 65. So alpha plus beta is how much? Cos of alpha plus beta is equal to so much. So what do you get? Alpha plus beta is equal to cos inverse of 33 by 65. Finally, substitute back for alpha and beta. Hence, we get the result or the problem is proved. Alpha is what? Substitute back. Cos inverse of 4 by 5. Plus beta is cos inverse of 12 by 13. Cos inverse of 12 by 13 is equal to cos inverse of 33 divided by 65, hence proved. So it depends upon the function present on right hand side. Because there is cos inverse, I consider cos of alpha plus beta. Sometimes they give minus sign in between. So in that case, I consider minus. So simple question, already asked in the exam for 3 marks. Move on to the next one. Proof is given here. Next one is here. This also same type. Take the first angle as alpha and second angle as beta. Then you consider sine of alpha plus beta. Let me prove this. Let alpha is equal to cos inverse of 12 by 13. Cos inverse of 12 by 13. Beta is equal to sine inverse of 3 by 5. So from this, cos alpha is how much? 12 by 13. From this, sine beta is equal to 3 by 5. We know 3, 4 and 5 are Pythagorean triplets. If cos alpha is 12 by 13, sin alpha is how much? 5 by 13. Because 5 square plus 12 square is 13 square. If sin beta is 3 by 5, cos beta is going to be equal to 4 by 5. Because 3 square plus 4 square is 5 square. They form the sides of a right angle triangle. Because there is sine inverse here on RHS, we consider sine of alpha plus beta. Consider sine of alpha plus beta. Consider sine of alpha plus beta. What is sine of alpha plus beta? The compound angle formula we have. Sine alpha cos beta plus cos alpha sin beta. Correct? What is sine alpha? 5 by 13. What is cos beta? 4 by 5. Cos alpha is here 12 by 13. Sin beta how much? 3 by 5. Multiply numerator to numerator. 5 into 4. 20, 13 into 5, 65, 12 into 3, 36, 13 into 5, 65, denominator is common, 36 plus 20 becomes 56. This is sine of alpha plus beta. So alpha plus beta is equal to sine inverse of 56 divided by 65. Substitute back for alpha and beta. Alpha is what? Cos inverse of 12 by 13 plus Beta is what? Sine inverse of 3 by 5 is equal to sine inverse of 56 divided by 65. Hence proved. Same way you can prove this third one. Take the first angle as alpha, second angle as beta, and right hand side what is it? Tan inverse. So consider tan of alpha plus beta. Take the first angle as alpha. Let alpha be equal to sine inverse of 8 by 17. Beta is equal to sine inverse of 3 by 5. Consider tan of alpha plus beta. Consider tan of alpha plus beta. What is tan of alpha plus beta? Tan alpha plus tan beta divided by 1 minus tan alpha into tan beta, right? From this you find the values of tan alpha. So alpha is sine inverse of 8 by 17. So sine alpha is 8 by 17. We know that 8, 15 and 17 are Pythagorean triplets. You take a triangle, mark the angle as alpha. Sine is opposite side divided by hypotenuse. This is 15. So tan will be 8 by 15. Tan alpha is equal to 8 by 15. And from this I can write sine beta is equal to 3 by 5. If sine beta is 3 by 5, tan beta is equal to how much? It is going to be 3 by 4, correct? Take a triangle, mark the angle as beta. Sine beta is 3 by 5, opposite side by hypotenuse. So adjacent side is 4. So tan beta is opposite by 3 by 4. Substitute the values of tan alpha and tan beta and simplify, you'll get the answer. Tan alpha how much? 8 by 15. Tan beta is 3 by 4 divided by 1 minus 8 by 15 into 3 by 4. Take LCM. 15 and 4. LCM is 60. 15 4s are 4 into 8 32. 4 15s are 60. 15 into 3 is 45. Denominator is 1 minus 8 3s are 24. 15 into 4 60. So this becomes 77 by 60 divided by, take LCM 60 here. 60 minus 24 is 36 divided by 60. 60 will cancel. We get 77 divided by 36. This is what? Tan of alpha plus beta. So from this alpha plus beta is tan inverse of 77 by 36. Alpha plus beta is equal, taking inverse, tan inverse of 77 divided by 36. What is alpha? Substitute back. Sine inverse of 8 by 17. And beta how much? Beta is sine inverse of 3 by 5. Beta is sine inverse of 3 by 5 is equal to tan inverse of 77 divided by 36. Hence proved. Similar type of question is there, I think, in the next one. You can prove it yourself. Take the first angle as alpha, second angle as beta, and consider cos of alpha minus beta, and write the formula for cos of alpha minus beta and prove it yourself. Solution is given here. If you want, you can make a note of this. Okay. Same way, we got one more question. We can start from right hand side here and get the left hand side. Take this angle as alpha, take this angle as beta, and consider tan of alpha plus beta. Write the formula, the compound angle formula for that, and prove it yourself. And the solution, if you want, is given here. Okay, please make a note of this. Move on to the next one. Solve for x. Sin inverse of 1 minus x minus 2 sin inverse of x equal to pi by 2. We want to get the value of x satisfying this equation. From the given equation, I can write sin inverse of 1 minus x is equal to pi by 2 plus 2 sin inverse of x. Moving this minus 2 sin inverse of x to right hand side plus 2 sin inverse of x. So from this 1 minus x is equal to sin inverse, to take that side, becomes sin of pi by 2 plus 2 sin inverse x. Sin of pi by 2 plus 2 sin inverse of x. Sin inverse, to take that side, becomes sin of, this is sin of 90 plus theta form. Sin of pi by 2 plus, call this as theta. Sin of 90 plus theta is cos theta. 90 means cofunction. Cofunction of sine is cos, using the concept of allied angles. Correct? 90 plus is second quadrant. Second quadrant sine function is positive. 90 means cofunction. So this becomes cos of 2 sin inverse of x. and this takes the form cos 2 theta. We know cos 2 theta is 1 minus 2 sine square theta, expressing in terms of sine. So cos 2 theta, I'll write 1 minus 2 sine square theta. What is theta there? Theta is sine inverse of x. If theta is sine inverse of x, I get sine theta is equal to x. Correct? So this becomes equal to 1 minus 2 sine square x, 1 minus 2x square. This is 1 minus x. Cancel 1 on both sides. I get minus x equal to minus 2x square. Cancel minus sign on both sides. We get x equal to 2x square. Or you can take x common. Correct? X common. X minus 2x square is equal to 0. X is common. So what remains? X into 1 minus 2x equal to 0. Which gives x equal to 0 or x equal to half. 1 minus 2x equal to 0 is 1 equal to x, or 2x equal to 1, x equal to 1 by 2 we get. So either x equal to 0 or x equal to 1. So verify the solution obtained is satisfying the given equation or not. So when x equal to 0, LHS verify. When x is equal to 0, what is LHS? LHS is equal to sine inverse of 1 minus 0 minus 2 times sine inverse of 0. 1 minus 0 is 1. Sine inverse of 1 is pi by 2. Sine inverse of 0 is 0. Pi by 2 minus 0 is pi by 2 equal to RHS. So x equal to 0 satisfies. When x equal to 1 by 2, what happens? When x equal to 1 by 2, LHS equal to. LHS is equal to what? Sine inverse of 1 minus half. Sine inverse of 1 minus half minus 2 into sine inverse of half. Sine inverse of 1 minus half. 1 minus half is half. Correct? Minus 2 times sine inverse of half. Sine inverse of half minus 2 sine inverse of half. This is minus sine inverse of half. Correct? Adding the like terms. This is equal to minus pi by 6. But RHS is pi by 2. Is not equal to pi by 2, which is RHS. So LHS is not equal to RHS. X equal to half is not a solution. X equal to 0 is the only solution here. Hope you understand this. Sine of 90 plus theta is cos theta. This takes the form cos of 2 theta. Cos 2 theta is 1 minus 2 sine square theta, expressing in terms of sine, because I taken this as theta here. Theta is sine inverse of x, so sine theta is x. Because I know the value of sine theta as x, I am writing cos 2 theta in terms of sine. 1 minus 2 sine square theta. Sine theta is x, substitute. Remove 1 on both sides, means 1 minus 1 is 0. Minus x equal to minus 2x square. X minus minus will cancel. X minus 2x square equal to 0. Don't cancel x, because x equal to 0 is also solution. We lose a solution. Correct? We can't cancel x equal to 0. If x is equal to 0, 0 and 0 can't be cancelled, because 0 by 0 is not defined. So x equal to x square, or x minus 2x square equal to 0. Take x common here. 1 minus 2x equal to 0. Equal to a into b, 0 means either a equal to 0 or b equal to 0. And verify the solution obtained is going to satisfy not. X equal to 0 satisfies the given equation. X equal to half does not satisfy the equation. So the solution is only x equal to 0. So x equal to 0 is the only solution. The solution is given here and the verification part is given here. Okay. X equal to 0 is the only solution. X equal to half doesn't satisfy the given equation. And finally, study about the graphs of inverse trigonometry function. Sine inverse of x, the principal branch is minus pi by 2 to pi by 2. I have drawn the graph of sine inverse of x in the closed interval minus pi by 2 to pi by 2, and x belongs to minus 1 to plus 1. In the principal branch, the sine inverse of x graph is shown here. Learn all the graphs of ITFs. Next we got the graph of cos inverse of x. The principal branch of cos inverse of x is 0 to pi, correct? So it lies only completely above the x-axis. And cos inverse of minus 1 is pi. Cos inverse of 0 is pi by 2. Cos inverse of 1 is 0. So graph of cos inverse of x lies above the x-axis, because the principal branch is 0 to pi. Next we got the graph of cosec inverse x. Cosec inverse of x lies in the interval minus pi by 2 to pi by 2 except 0. So graph is like this. Cosec inverse of 1 is pi by 2. Cosec inverse of 0 is infinity. Because cosec inverse of minus 1 is minus pi by 2. Cosec inverse of 0, that is minus 0. That is 0 minus is going towards minus pi by 2. Graph of secant inverse of x. I think there is a correction here. This should be pi, okay, not pi by 2. This is pi here. Pi by 2 is here. Graph of secant inverse x. This is not pi by 2. This is pi. We know the range of secant inverse x is 0 to pi. Closed interval 0 to pi. Pi by 2, there is one asymptote here. Horizontal asymptote, not vertical asymptote. In the graphs of trigonometry function, you can see vertical lines, vertical asymptote. Here we got horizontal asymptote. because the range of secant inverse x is 0 to pi except pi by 2. Pi by 2 is excluded. So graph of secant inverse of x. Secant inverse of 1 is 0. Correct? Secant inverse of infinity is pi by 2 because secant pi by 2 is infinity. Secant inverse of infinity is pi by 2. Correct? Cos pi by 2 is 0. Secant pi by 2 is infinity or not defined. So graph of secant inverse of x in the interval 0 to pi. Next we got the graph of tan inverse x. It lies in the interval minus pi by 2 to pi by 2, open interval. So I have put a dotted lines here because the interval is open. Pi by 2 and minus pi by 2 are excluded. Tan inverse x is increasing function, correct? And finally cot inverse x. Among the 6 inverse trigonometry functions, no, cos inverse, cot inverse and cos inverse are decreasing function. Sine inverse, tan inverse and sec inverse are increasing function. The 3 C's are decreasing function, remember. Cos inverse, cot inverse and cosec inverse, they are decreasing function. Even cot inverse x decreasing function. This is pi here. Open interval 0 to pi, cot inverse x. Okay, graph of cot inverse x in its principal branch, open interval 0 to pi. So graphs of all ITFs are shown in its principal branch. And next in the next video I'll be doing some of the important deleted topics also, and also I'll be drawing the graphs of sine inverse of sine x and cos inverse of cos x, etc. And I'll be doing CET session on this, the synopsis part of ITF for CET as well as JE also. Then we can work out the questions connected to this. Also, I'll be working out some of the important MCQs which can be asked for the board exams. Okay, board exam MCQs will discuss of this ITF chapter and fill in the blanks type of question as well. Okay. So with this we can conclude, we finish the chapter ITF entirely of the NCERT book, and also I'll be discussing one more topic, that is if two functions f and g are such that they're inverses of each other, then their graphs are mirror images about the line y is equal to x. That is one more concept to be discussed. I'll be discussing that as well, about the graphs of f and f inverse, how they are related to each other. Sin x and sin inverse x, they are going to be mirror images about the line y is equal to x. Okay, about the graphs of function f and its inverse of the function and the properties also. Graph of sin inverse of sin theta or sin inverse of sin x, or I want to draw the graph of sin inverse of sin theta is equal to theta if theta belongs to the principal branch of sin inverse, closed interval minus pi by 2 to pi by 2. Cos inverse of cos theta equal to theta if theta belongs to closed interval 0 to pi. Want to draw the graphs of such functions, sin inverse of sin theta, cos inverse of cos theta, because such kind of graphs are helpful even in finding the area under the curve. In application of integrals they can ask questions, JE level questions. Okay, and also we can discuss the differentiability of such functions, whether it is differentiable or not. So all are related topics. Inverse trigonometry, if you know trigonometry, then we can study inverse trigonometry. Concepts of trigonometry and inverse trigonometry is a very foundation for study about the calculus part, mainly differentiation and integration. If you know differentiation, then we can study application of differentiation, integration, application of integration, differential equations, all are connected to each other. So you can't neglect any of the topics. So hope you enjoyed the classes, hope you gained some knowledge listening to my classes of ITF, starting with all the basic domain and range of ITF, and also we studied the inverse of the function, finding the principal values, important simplifications in trigonometry and inverse trigonometry by making substitution, root of 1 minus x square, root 1 plus x square, all those things. We had various substitution, simplifying given inverse trigonometric equation or expression, how to solve an inverse trigonometric equation also we discussed, and also verified the solution obtained is going to satisfy or not. And we discussed the graphs of inverse trigonometric functions, the 6 graphs we studied, and also we had the simplification of a given inverse trigonometry function, and also the application of double angle and triple angle formula, and also deduce the condition for which the equation holds. All these things I have discussed in detail in this session. Okay, with this we'll wind up for this session. In the upcoming classes we'll discuss more of ITF, which is required for maybe CET and JE point of view. Okay, with this we'll conclude. Thank you.